Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will discuss about the steel casting part 2. We have already gone through some of the portion of the steel casting. Now I want to continue that the problem regarding steel casting process. We have discussed about different types of mold to be used for steel casting. Now, cores are important problem in mold in mold during molding, because you see, due to high pouring temperature, larger core gases are generated, moisture content, gases, and the gases produced due to the reaction with the volatile material in the molding sand. They become voluminous, the volumes increases, and therefore the gases being generated as that also in the core, and therefore the core should have a greater permeability, and not only this, but it can be added by having hollow shelled molded cores, because due to the inefficient cores there can be defects like hot tears. Now steel starts freezing very soon after being poured in the mold cavity. Freezing takes place, it starts, and there is a relatively rigid core will cause to form hot tears, and not only this, metal penetration into the core will also take place to a finite distance, and the hot metal will react with the surface of the core and and oxidize the surface, and also the metal will penetrate into the oxides, and the oxides may be that of silicon, alignment, the elements of the core sand, with silicon, magnesium, aluminum. They solidify and get intermingled with the sand grain and gives a very glassy surface, and very difficult to machine that surface out, and therefore the precaution should be taken regarding that. Now, there were core sand and core mold washes can be used at the interface to protect the surface of the molten metal during solidification. There was a function of the core and the core washes and sand washes can be to prevent metal penetration, to eliminate cutting, erosion of the surface of the mold cavity, and to prevent scabbing, give a smooth surface, casting surface, and have a clean casting surface. Now it won't react with it won't allow to react with the molding sand. The core sand will form the interface, and therefore we can have a clean casting surface, and therefore it will also modify the mold atmosphere and this is cleaning the casting. The composition of the core washes and mold washes are maybe silicon flour and mixed with bentonite, or can be magnesite, bentonite, and benzoate. Other alternative can be silicon flour, bentonite, where the water soluble resin. They just have a very fine coat on the mold cavity to give the space of the cavity. Now there was another thing, a solidification factor, which is also taken into consideration because the temperature level of solidification is high and the range of solidification is also high. The steel solidify at a very wider range. If you look into the phase diagram, then you will see that the steel has got a very wider range, and also the level of solidification also very high, and therefore we have to consider all these factors: thermal conductivity of the mold and thermal conductivity of the steel. After solidification, the surfaces, they will also, the thermal conductivity of the steel will also cause to have to affect the solidification of the remaining molten metal. Gravitation and convection will also affect the solidification of flowing stream when the molten metal is flowing, and therefore during that solidification also takes place, solidification also taking place, and therefore that is also to be considered. Moreover, solidification time, depending upon the size of the product, bigger product will need more time, and therefore all these problems will affect the solidification process. Shape factor will also, and therefore according to that we would have to design an optimum efficient gating system. Now, defects attribute to poor gating system. Therefore, it should be very effective and properly designed. This gating system may cause erosion if the flow of the metal is not being properly controlled, may cause to have hot tears and dimensional instability. Slag may get entrapped due to poor gating system. Cold shut may take place. The flowing stream may not get intermingled with each other and have a uniform fluid, uniform diffusion into one another, and therefore cold shut may take place. Flowing metal may come in contact with the entrapped gases, and oxidation may take place, and there can be a misrun, and wrinkling defect may also take place. Therefore, we have to design a proper gating system. Say, for example, riser. Now, Kant's method can be adopted to design a riser. Padding section can be used to gain directional solidification. Now, this padding section will enhance the solidification time in the riser, and or exothermic riser can also be used to reduce the size of the riser. Now, steel mating. Now, steel can be mated in open hearth, acid or basic, electric arc, acid or basic, electric induction, acid or basic. The charge can be in the furnaces. The charge can be scrap and pig iron, so that we can have the desired composition of steel. Now, we have to take care so that deoxidation may also be adopted, so that the oxygen dissolved in the melt may be lowered. They were adding elements like silicon and manganese. They react with oxide, and they will form oxides of these metals which are lighter and that can be skimmed off. Adding aluminum to the ladle during pouring will also cause to react with these oxygen and give slag, which will float and can be skimmed off. Now, after solidification, we have to take out the casting and The removal of gears and risers is to be done by using mechanical ways like bend saw, power saw, abrasive cut-off tools, or can be used torch cutting mechanism. Now, after cutting, the surface is to be cleaned. That can be cleaned by putting all those product casting in a tumbling mill. It is a big drum rotating mill. While rotating, each component will strike each other and abrade the surface of the same. After that, sandblasting can also be done so that the surface will be maybe from clean, will be very clean, very neatly. Now, if the surface, if the material has got certain defects, that can be repaired or can be salvaged. Or if the structure is very big, then we can produce small parts and weld them together so that we can have a composite structure. Now, the steel are divided into two major classes. Now, low alloy steel, which is having a limited alloying element up to 8%. Now, this alloying steel has an ability to heat treatment and has higher hardness, higher strength. Common alloying elements are manganese, chromium, molybdenum, nickel, silicon, copper, vanadium, and other the combination of this. That can be high alloy steel. Now, if the alloying element is more than 8%, then it is classified as high alloy steel. Now, that gives superior corrosion resistance. It can be heat resistant, it can be wear resistant. Depending upon the requirement, we can have alloying element higher than 8% so that we can achieve all these properties. Now, some of the example of high alloy steel are given over here. Iron with varying 12 to 30% chromium, iron varying from 18 to 32% chromium, and 8 to 9% nickel. Similarly, iron varying from 33 to 41% nickel, and 13 to 21% chromium. Similarly, iron with 58 to 68% nickel and 10 to 19% chromium. Similarly, other alloying may also be used as departing upon requirement, and that can be silicon, molybdenum, aluminum, etc. This is all about foundry of steel casting. Thank you. Assalamu alaikum.